Assalamualaikum warahmatullahi wabarakatuh. To our beloved panel, Dr. Nur Hayati and Puan Suhaila. So, this is a video of our presentation to bring forward about our final year project. Before going through, I would like to introduce my group members. So, the first one is Nur Atirah Ilyani binti Rani, Muhammad Nur Iqbal bin Sumawan, and last one is me. My name is Tuan Muhammad Fikri Haziq bin Tuan Azwan, and we with our supervisor, Dr. Nurul Huday binti Abdullah. As you can see, our topic project is phosphate absorption from synthetic solution by using waste mushroom shell. So, what is this project about? It has been a long time that water for the environment is very important tool to ensure the natural system survive. But recently, the amount of domestic water have been discharged increasingly with nutrient, which is nutrient pollution contain nitrogen, carbon and phosphorus. So, our project is going to solve a problem with the villages at Kampung Pasir Putih, Johor Bahru, where the sustainability of mussel shell are waste to landfill. About phosphorus. Physical properties of phosphorus are the characteristics that can be observed without changing from the base of the substance into another new substance. Phosphorus is important existent but can cause harm to human and living things. When the phosphorus close the water surface, eutrophication can happen and the plant cannot do the photosynthesis process. So, we are going to do outstanding method, that is using waste mushroom shell to remove the phosphorus. Okay, mussel shell. Mussel shell is one of the product of the aquaculture industry that is used as abundant residual source of calcium that can recycle in wastewater treatment. Mussel shell after treatment has high calcium oxide, which is effective component for the phosphate removal. So we have decided to make use of the waste mussel shell since the uncontrolled release of effluent to natural water bodies increases health risk for human beings and cause environmental pollution because of the waste mussel shell can be used to overcome waste pollution observed to the chemical substance. Now we're moving to next part, that is problem statement. For our project, there is two problem statements. First one is the industry release chemical substance in water, and the second one is the waste mussel shell that have been thrown. Okay, while for the objective, we have three objectives. First is to study the potential of waste mussel shell in removing phosphate from aqueous solution. To study the efficiency of the absorption process by performing basic absorption isothermal and also kinetic study. The last one is to observe the effect of different parameters on phosphate removal. For the material and methods, mussel shell were collected from foreshore in Pasir Gudang, Johor. For mussel shell is being mostly used and wasted to landfill. This will make that place smell and dirty. So to solve this problem, we use mussel shell as an absorbent to remove phosphate. Mussel shell is suitable for this project because it have high content of calcium that can reduce the phosphate in water. This is the overall flow that we must follow to make sure our project is successful. So the first procedure is we must to do literature review. The next is preparation of absorbent, which is have 2 gram, 4 gram, 6 gram and 8 gram. And the third procedure is we must to prepare of aqueous solution, that is have 5 ppm, 10 ppm, 15 ppm, 20 ppm and 25 ppm. Next is batch test experiment, and last one is parameter analysis, which have two methods, that is absorption of kinetic and absorption of isotherm, which is absorption of kinetic contain of pseudo first order and pseudo second order, and for the absorption of isotherm contain of Frelich model and Langmuir model. Okay, for the preparation of absorbent, after collect the mussel shell at Pasir Gudang, Johor, The master shell should be washed whole with tap water and make sure the master shell is in clean condition. After wash, the master shell will soak under the sunlight and dry in and on oven at 30 degrees for 3 days. Crush and sieve it pass through 0.6 mm, 1.18 mm and 2.0 mm sieve proportion. The size range of 0.6 mm to 1.18 mm was chosen for this experiment. After obtaining the crushed powder in the range of 0.6 mm to 1.18 mm, the master shell were packed according to their weight, that is 2 gram, 4 gram, 6 gram and 8 gram.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Sumawan. So today I would like to present about the preparation of aqueous solution. For prepare 1000 ppm of aqueous solution, for the first, weight the phosphorus to 0.433 gram and then put the phosphorus to the volumetric flask and add distilled water until 1 liter. Next, dilute 1000 ppm to 30 ppm. How to dilute 1000 ppm to 30 ppm? Alright. Take 300 milliliter from 1000 ppm and then put into the new volumetric flask and add distilled water until 1 liter. Next, dilute 30 ppm to 5 ppm, 10 ppm, 15 ppm, 20 ppm and 25 ppm. For the test, add 1 milliliter of acid amino and molybdate in each test. Insert the sample into the DR6000 and then we'll get the result. So next, I will go through explain about the pseudo first order and pseudo second order, PFO and PSO. So what is PFO? The pseudo first order kinetic model assumes that the rate of occupation of absorption site is proportional to the number of occupied sites. For second order, pseudo second order kinetic model assumes that the rate of absorption of solutes is proportional to the available size on the absorption. Thus, the reaction rate is depends on the amount of solute on the surface of the absorption is proportional to the number of active site available on the absorption. Alright, on this slide, you can see the linear form for pseudo first order and pseudo second order. Next, the plot for pseudo first order, ln QE minus QT versus TI. And for the pseudo second order, TI over TQ versus TI and the parameter. Alright, this is table kinetic. On this slide, have two table PFO and table PSO. So this table for 2 gram. In this table has C, sample, CI, QE, K1 for PFO and K2 for PSO. And the correlation coefficient R2 on both table. And the last QE. The value we can get from the kinetic absorption graph. So next on this slide is about result analysis kinetic absorption. On this slide, you can see the graph of pseudo first order and graph for pseudo second order. Okay, from the pseudo first order graph, the y-intercept of the isotherm model is negative 3.2281, which is equivalent to ln QE. By solving the ln QE through exponential solution, the value of QE is negative 0.0015. The value of QE is the procedure first order constant or the absorption capacity of the system. The R2 remind the correlation coefficient of the absorption system to the isotherm model. In this case, the R2 obtained from the linear model is 0.98. So next, from pseudo second order graph, the y-intercept for the line is 4448.47.4, which is equivalent to 1 over K2 QE2. Solving the y-intercept helps identify the maximum absorption capacity K2 QE2 for this study, which is 2.244. By applying the value of K2 QE2 into the equation, K2 can be calculated, which is 0.083 for the procedure second order model. In this study, the correlation coefficient R2 obtained from the linear trend line, which is 0.9991.
Hi, my name is Noor Atira Ilani Mitrani, and I will be presenting about the absorption of isotherm and the conclusion. Okay, now let's move to absorption isotherm. So for the absorption isotherm, we use two equations. For Freundlich, we use the equation of ln QE equal ln KF plus 1 over N. E is the equilibrium amount of phosphate absorbed. Then N is the factor of heterogeneity and CE is the equilibrium concentration. For the Lamuet equation, it can be represented as 1 over QE equal to 1 over KL Qmat CE plus 1 over CE. QE is the equilibrium amount of phosphate absorbed. Qmat is the absorption capacity. KL is the absorption energy constant. This table is the value of QE and CE. This is for the Freundlich isotherm. This is the value of ln QE and ln CE. Okay, next this is the graph of ln QE versus ln CE. The Lamuet isotherm, this is the value of 1 per QE and 1 per CE. So the graph is 1 per QE versus 1 per CE. Okay, this is the graph. Okay, lastly for the isotherm, we need to form it into a table. This is the table for Lamuet. We can see the Qmax, KL, and R square. To know the value of R square, we can find it from graph. Okay, next we move to the conclusion. For the conclusion, in this work, which muscle cells have been used as adsorbent for eliminating the phosphate. Study has shown that the muscle cells as an alternative for reduction of phosphate, addressing the costly and troublesome of water disposal. Reduction phosphate by adsorption is an existing method due to eco and fast running. Moreover, muscle cell after thermal treatment has higher calcium oxide, which can absorb the phosphate from wastewater. Results demonstrate that the removal efficiency could improve while the concentration of phosphate decrease. By using the process, the environment will be safe and can be treated well, and the beach pollution can reduce by collecting the muscle shell. That's all from me.